Welcome, geometry students. So glad you could make it today. Today we're doing Chapter 2, Lesson 2.4, despite what it says on the sheet. And this is a Kuta software worksheet tutorial. One thing I think that's kind of cute is it says mathematician instead of name. So anyway, let's go ahead and get started. It says write each of the following statements as conditional. We've already kind of done a video on what conditional means. So we'll kind of give just a brief review, and then we're going to move on to a little bit more important matters. So number one, the measure of a straight angle is 180 degrees. Now, when you're dealing with these types of problems and you want to make them so they're written as conditional, you can add a few words, and it really doesn't matter which one you consider the hypothesis or conclusion. So we'll just go ahead and say if an angle is straight. Sometimes you just have to think it through a little bit. Then it measures 180 degrees. So you can see I added some words, I took out some words there, but we just needed to make sure that we got a conclusion. So that's my Q, and then we had a hypothesis right here. An angle is straight, hypothesis, it measures 180 Q, okay? We'll just kind of say this one. Anyone who has never made a mistake has never tried anything new. We could write this as, if you have never made a mistake, then you have never tried anything new. That would be an easy way to do this one. And then number three, we could write, if an event has a probability 1, then it is certain to occur. So we could just say that this is our P and this is our Q. Let me get this whole thing underneath there. Okay. That's just a quick review. Now, this is a little bit more important. For the given statements, write the converse, inverse, and contrapositive. So the conditional is given to us. This is conditional. So the first thing we got to do is identify the hypothesis and conclusion. A point is a midpoint of a line segment. Then it bisects the segment. Okay. So now for conditional, we know is P arrow Q. And we're going to be doing this a lot, so I'm going to go ahead and just copy paste this, okay, for the next one. But for converse, which is the next form, it's not P arrow Q. It's not if hypothesis then conclusion. It is if conclusion then hypothesis. So we just need to switch this around. I'll write this once, and then again I'll copy and paste. So the first thing we're going to write, and I'm going to include the if statement in blue, even though the conclusion doesn't really have the if statement. If a point, we need to add a few words here, bisects a segment. Okay, so we just need to kind of make it work with English, even though the mathematical concept is the same, and we're just switching it around to make the converse. Then the point is a midpoint. And I could have said it is a midpoint. I just decided to add point. Then the point is a midpoint. Okay, so we changed it. Q in front, and then hypothesis in the back. Now, inverse is the next statement we're trying to write here, inverse. And this is also a little similar, but now instead of just P then Q, we're going to have the negation of that, which is not P, then not Q. Okay, so we're going to take this, we're going to grab this guy. The point is the midpoint, copy, paste. We're going to change this slightly in just a moment. Copy this guy, paste. Okay, I'm going to move this stuff over just so we have a little bit more room. Okay, let's get to it. If the point is not a midpoint, we have to add the word not because we're using negation. That's what that little squiggly line means. If it is not a midpoint, and now we're going to add the word then, and again we're going to say not. Then a point does not, we'll say, bisect a segment. Does not bisect a segment. Okay, that's what inverse is. We just keep the conditional exactly the same, and we just negate each of the statements. So we had a not or a no or whatever it's needed to negate it. Now we're on to contrapositive. Contrapositive is similar to inverse, except it's reverse. So we need to move the converse to the front, the hypothesis to the back, and it's essentially the same thing again. So I'm going to take this. Hopefully I can clean it up a little bit with better handwriting. Okay, let's move this over. Does not, and we'll erase this. And we're at if, and then I'm going to write contrapositive. Contrapositive. If a point does not bisect a segment, copy paste, then the point is not a midpoint. Copy paste. And now I need to add the word then. All these are if-then statements. And there we go. That's how you do conditional, converse, inverse, and contrapositive. It's just kind of a rearranging. Hopefully you see that it's not too complicated. We could do the same thing here. Just make sure you understand that this is your P to start. This is your Q. And then we should have done this one, far less writing. And then you just follow these statements again right here for this one, okay? Really should have done that one instead. Okay. Now we're on to I guess we can go with number 6. Your classmate claims the conditional contrapositive of the following statement are both true. Is he or she correct? So conditional is if, then, this is the conditional. And this is true, okay, because we can test this. 2 squared is equal to 4, okay? And the contrapositive, we'll have to check this one. Now, the contrapositive says, first we identified this is our hypothesis, this is our conclusion. So we're going to say if x squared does not equal 4, okay, then x does not equal 2. Okay, very similar to what we'd be practicing up there. Again, contrapositive is not Q, then not P, so we just switched it and then negated it. So if x squared does not equal 4, then x does not equal 2. So this one is actually also true. There's no way to have something that's, if this is not equal to 4, then that's not equal to 2. Obviously, 2 squared is the only thing that can give you 4, so it can't be 2 if this is not 4. So that is true. Okay, so now we are on to write a true conditional that has a true converse. This one's fairly simple. We just have to write something like, let me go ahead and think of something. If an angle is right, then it measures 90 degrees. I'm struggling with that word today. If an angle is right, then it measures 90 degrees. If you switch it, you have if an angle measures 90 degrees, then it is right. The reason why this is good is because this is a definition. Anytime you have a definition in mathematics, it's conditional and converse are always going to be true because that's what makes a good definition. Write a true conditional that has a false converse. And this one's a little bit more fun. We can say something like, if it is dark, no, if it is midnight, then, oops, blue, then it is dark outside. Okay, well, let's just assume that we're not in somewhere very north, where we have 24-hour daylight during the summers or anything like that. So this is just the assumption. Okay, now let's reverse this statement. What does it say? It says, if it is dark outside, then it is midnight. That is definitely not true. Imagine if the sun sets at 9 o'clock, then it's going to be dark at 10. So this is not the converse. When you flip it, when you put the Q first and put the hypothesis second, it does not work. It is false. All right, draw a Venn diagram. We'll do maybe like one or two of these real fast. So in order to do a Venn diagram, essentially the then statement is the big one. So, whoops, I'm not sure why that didn't work. Let's try this again. There we go. This one is the big one. So this is my Q, and then my P goes inside in a smaller circle. So this is my P. Okay, so this is 105 degrees, and these are obtuse angles. Obviously, there's a lot more angles that are obtuse than 105 degrees. Like we could have 91 degrees over here. We had 120 degrees over here, each with its own little circle. So they're all part of the bigger umbrella of obtuse. So that's kind of how Venn diagrams work. The conclusion, if it's written as just a true conditional statement, is going to be on the outside, and then the hypothesis will be on the inside of that. Okay, we'll do a few more just so you guys get the hang of it. Each converse as a statement. If the converse is true, write true. If it's false, provide a counterexample. So this is a good one to start off. This is the only one I'm going to do. I think the other ones, most of them are true. So here's our conclusion. If we write the converse, it says if absolute value of x equals 6, then x equals -6. This is not true because x could also equal, this is my counterexample. So counterexample would be x equals +6, because that is true. X, for absolute value of 6, it could be 6 or a -6, so that's my counterexample, so that is not true. Write each postulate as a conditional statement. We've already done stuff like that. Let's skip down to biconditionals. So biconditional, this is a little bit different scenario. This is where we have a true P and a true Q and a true converse and a true converse. True conditional and a true converse. So it's written as this. This is biconditional right there. Okay. The only difference with this is you make a statement. You don't start your sentence off with if. You start it with the actual statement. This one you might need to reword it a little bit. You need to make it fit with English. So we can say a point. Notice how I didn't start with if. A point is in quadrant 3. And this is the cool part. If and only if. This is what makes it biconditional. It has two negative coordinates. So that's what makes it a biconditional, is really this. Notice how I don't lead, whoops, there's no if and then kind of sandwich, an if there and then there. There's none of that. Okay, so I can talk you through the next, let's go 21. The whole numbers are non-negative integers. We can say a number is whole, whoops, and it doesn't really matter which one you start with. I mean, I chose this P and Q as blue and whatever, so I'm just going to show you that you can go in any order with the Q first or the P second. Doesn't really matter because you can switch them anyway. So a number is whole. Notice how I didn't start with if. And then this is our key part that makes it biconditional. If and only if it is we'll say a non-negative integer. So you see that I went singular instead of plural. I could easily make it plural by saying numbers are whole if and only if they are non-negative integers. Singular is pretty much saying the same thing. The main thing is understanding how to frame it in a biconditional statement. I hope you guys found this video helpful. Thank you for watching, and I'll see you next time on West Explains Best.